I want to go outside and work out today. Only one problem. I live in Phoenix, Arizona, and the high temperature today is likely to hit 45 degrees Celsius or 113 degrees Fahrenheit. Yikes! Yet, as hot of a location that Phoenix is, hence why I live here, what I just described is truly a less common extreme, with the true yearly average temperature of the city being 23.7 degrees Celsius or 74.7 degrees Fahrenheit. While that still might sound fairly warm for a lot of people, you might be surprised to learn that the true average temperature of our planet has widely varied throughout its 4.543 billion year geologic history. This has caused extremes ranging from a time when the vast majority of our world was covered in thick ice sheets with only an unfrozen equatorial region, a slushball Earth if you will, to a literal hellscape unsurvivable to any life forms, ranging in the thousands, yes thousands of degrees Celsius. But, when did these temperature extremes occur, and what can they tell us about major events in Earth's geologic past? Today's video will attempt to answer these questions. Earth's hottest periods. First, the hottest the Earth has even been was somewhat soon after our planet coalesced from planetoids and asteroids colliding with each other and merging 4.543 billion years ago. With the absurdly frequent massive impacts occurring around the planet, Earth upon its initial formation was almost completely molten, having a surface temperature of around 1700 degrees Celsius. However, when a large protoplanet known as Theia, which was about the size of Mars, collided with proto-Earth 4.53 billion years ago, it not only led to the creation of our moon and enlargement of Earth to its modern size, but also truly made Earth completely molten with a surface temperature averaging 2000 degrees Celsius. And this is the hottest Earth truly ever got, sufficient to melt both steel and solid elemental iron. However, what I just described is truly a boring answer. So, let's quickly fast forward to a point when our planet entered a permanent, relatively stable trend not in the range of hundreds or thousands of degrees Celsius. Specifically, since 3.5 billion years ago. With that range in mind, when was Earth truly at its hottest? The answer is 251.9 million Permian-Triassic extinction years ago, during the worst mass extinction event our planet has ever seen. What I am referring to is the Permian-Triassic extinction event, which is also referred to as the Great Dying. This mass extinction was triggered by the eruption of absurdly large floods of lava termed flood basalts, which occurred in what is now modern-day Russia. Across a 2 million year long time span, these floods of lava completely covered 7 million square kilometers of land in a whopping 4 million cubic kilometers of molten rock. These eruptions occurred intermittently, first causing extreme cooling due to the volcanic winter they generated. However, such cooling trends would be over in years to decades, only to be followed by a steady increase in temperatures caused by the vast amount of carbon dioxide released into the atmosphere. This process repeated thousands of times, making it impossible for most species to survive, and causing average world temperatures to rise from 26 degrees Celsius to an average of 35 degrees Celsius or 95 degrees Fahrenheit. At the equator, the average water temperature reached 40 degrees Celsius or 104 degrees Fahrenheit. But, when was Earth its coldest? Earth's coldest periods. This question has two potential contenders, although one is a better candidate than the other. Both of these periods involved extreme long-term drops in temperature where glaciers spanned almost the entire globe with only a fairly narrow ice-free band at the equator. The first candidate is the Garganda Formation of the Huronian glaciation, dated to approximately 2.3 billion years ago. This series of glaciations was likely triggered due to the Great Oxygenation Event, aka the first widespread appearance of oxygen in our atmosphere. This oxygen reacted with an incredibly potent greenhouse gas, methane, to create two lesser greenhouse gases, causing worldwide temperatures to plummet to an average of around -5 degrees Celsius or 23 degrees Fahrenheit. However, what I think is the true coldest period in Earth's geologic history was the first and cryogenian period, most severe of two aptly named cryogenian period glaciations referred to as the Sturtian glaciation. Between 717 and 660 million years ago, average world temperatures may have dropped as low as -12 degrees Celsius or 10 degrees Fahrenheit. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.